This is my third video. It's going to be really quick over probability distributions, specifically binomial probability distributions. And I'm just kind of in this video recapping the formula that we use, but trying to advocate for using the binomial distribution tables as opposed to using the formula itself. So to kind of talk about the difference between the two approaches, let's go ahead and take a look at this example. It says a report from the Secretary of Human Services, Health and Human Services stated that 70%, so 70% of single vehicle traffic fatalities occur at night on weekends. They involve intoxicated drivers. Wow. So we say if a sample of 15 single vehicle traffic fatalities that occur at night on a weekend is selected, find the probability that exactly 12 involve a driver who's intoxicated. So again, let's start with this. Why is this a binomial experiment? Okay, well, it's binomial because either that involved an intoxicated person or it didn't. So we say in this case, and this sounds really bad, but we tend to classify things as either a success or a failure, since the probability that we're searching for, that is, looking at the last sentence, the probability that exactly 12 people involve somebody who's intoxicated, we're going to say probability of success is probability that we get somebody who's intoxicated, so intox. Okay, so we say success is intox, we say not intoxicated, then would be this failure down here. But that being said, let's go ahead and write down what we need to know about this before we plug it into the formula. Starting with this, our sample size, or the number of trials of this experiment, or this number of people. So we said, well, we had 15 single vehicle traffic fatalities that occurred at night on a weekend, so we say 15. And we say we want to find the probability that exactly 12 involve an intoxicated person. So we say X, which is the number of successes or number of intoxicated people, in this case is 12. Other things include the probability of success. Now in this case, in past problems, I've given the probability of success and failure. In this case, I just say probability of success is 0.70, and it was given to us. So the probability of failure would be the other 30%, or 1 minus P, which is the probability of success. But this being said, we say we could find this using the formula. That is, find the probability we get exactly 12 successes. And so if we were to use the formula, recall the formula, we have it written up here. We say it starts with the number of trials on top. So we say the number of trials, and we say 15 factorial, which in and of itself is a ginormous number. And then in the basement, we'll put in the number of successes. So we say 12 successes. Let me switch back to red here. 12 successes. So if 12 successes out of 15, there are 12 successes, then we say the other 3 are failures. And then we'll just fill in the probability of success and the probability of failure over here, and the number of each. So we say probability of success, we said 70%. Success rate, well, then there's a 30% failure rate. And furthermore, we can just plant these numbers that we had written down here in the denominator up here, 12 successes on the probability of success and 3 failures on the probability of failure. Before we evaluate this, and actually I'm not even going to evaluate it, I just want to go to show that this would be a mess. If we actually had to type this into a calculator, it's not impossible to do. As a matter of fact, this is entirely reducible right here, and we could type these things in, but it's not desirable. So again, to use the tables, we're going to need to know 3 things, starting with this. We need to know N, which is the number of trials, X, which is the number of successes, and P, which is the amount or the probability of a success in the first place. So we have 15, 12, and 70% respectively. Let's go over to the table. So the first thing we want to find is our sample size. We need a sample size of 15. We notice that 15 is right here. Also this, we say, well, 12 successes. So, we say R, which is X in our instance, we'll go down to 12. So we say, here's my 12. So we have 12 successes. We need to go over to the column that contains 70% success rate. So if I were to trace this down here, or trace over, I try to get this lined up here, right? We say this is my, there it is. 70% success rate column runs into my 12 successes row in my 15 size sample. It gives us 0.170. So we get this. We get probability of 12 successes is about 0.170, I think is what we just discovered. Or, a 70% chance, 17% chance. Or probability of that occurring. So, let's put it this way, 70% of drivers we would expect to be intoxicated. In the first place, we had 15 people in our sample. 70% of that would be 10.5 people. So we say the probability that we get exactly 12, is still pretty good. And it's not good. Don't drive drunk. Don't, put yourself in that situation. I'm saying it's a pretty good chance that, we'll get what we expected to get in the first place. Cheers.